Welcome back to Engineering Drawing with SolidWorks. I'm John Filkey, and in this presentation I would like to present the topic of detailing assemblies. The intended learning outcomes from this presentation are that students will be able to identify the components that are shown in a bill of materials, create an assembly drawing to the requirements of AS 1100, and explain why always documenting drawing revisions is necessary. So in SolidWorks, we have a range of choices. We can create a part, assembly, and a drawing. So in here, multiple parts are put together as an assembly, and then those assemblies are shown on a drawing. So generally a part has a part number and a description. So we can create them in SolidWorks under the custom properties, and in this course it's not so important, but if you're using it as a SolidWorks user, you would then have these pre-set up so they pre-populate into your bills of materials. So we have parts, then go into an assembly. So an assembly of those parts have a new part number and a new description. So we're made up of parts and description, part numbers and description, which go into another part number and a description. So there's a hierarchy, and then sub-assemblies go into assembly, which go into another assembly, and keep going there. So when we are creating parts, think about making things that are mated to the origins, to planes. Then you can make the planes, you can make surfaces, you can make them coincident, you can make them concentric. And if you try mating planes together rather than mating faces together, because if a face changes or is deleted, you'll lose your mates for those parts. So it's much easier to mate between planes rather than surfaces. So with regards to AS 1100 and drawing and specifying assemblies, it's very similar to the parts that we've had before, that we've talked about. So in this exercise, I'd like you to look at the picture here, and then you might need to look at the slide to actually see it clearly in the PDF, but identify what is the sheet size, when was it drawn, the drawing number, who drew it, what the description, the company name, and the view projection that's used. All these things must be shown so that you know how to make these parts or to assemble them. So in the top right hand corner was a bill of materials which showed the item number, the part number, description. So descriptions might be the same quite often, but unique. The part number needs to be unique. So that's really the ultimate identifier. But numbers are really hard to remember, and if we get the part number and the description, we're going to be probably very close to always having the right part. Quantity, how many, and often it shows material and what it's made out of. So that is placed in the top right hand side of the drawing. So if you remember, down the bottom we have the title block. So we have the title, and at the top we have the bill of materials on there in the drawing, and then we have this space over here left for our drawing on the drawing sheet. So here's an example of an assembly. So what we have here is a pin and a retaining lug. So it's showing how it's fitted together. There's weld symbols, there's distances showing where those parts are located. But most importantly is the bill of materials. So we have the item number, we have the part number, description, and quantity. So materials not always necessary, but those ones are very much needed here. So there's some drawings I've been involved with my time with Howard Bagshaw, where I was 13 years as the manager of R&D. So we can also take these assemblies and use this for parts books. So here's an exploded view. It's the front of a scurry bar, part of a cultivator, and then we use the same bill of materials to show the items here. So we have item number 1, we can find item 1. So you can find item 1, there's item 2. Item 1 would have to be shown there if you look for it. So we've got the items here. So let's have a look. Oh, there's item 1 over there. So item 1. So we can line up item 1, item 2, see what they are and where they are to help identify them. So the one thing is we can create drawings and we can keep modifying those drawings until we start releasing them and giving them to people. So if we give a copy or a draft to a potential contractor who's going to make it, or someone to give us feedback, we need to then start putting revision numbers on there. So we need to, so if we've released the drawing, given it to someone, we want to then be able to track those so that we know that we're talking about the right drawing. It's no good if people have got the drawing but we've made a change to the dimension or the shape, and we need to know that. So we often denote it revision A, revision B, etc., just going up there. And then we often note on the drawing what those revisions are. So we need to track those revisions so that we can be in control and know that we are talking to the people about the right version of that drawing. So it's very important to have this version control. Now here's an example of a part here that they've done a revision. So you can see here, now we've got a revision note, and there's some questions there for you to think about. What was the revision? When was it made? What was the revision number? What is the drawing number? What would you call the next revision if we did another one? And what would be the drawing number for the next revision? So that's some questions to have a look at that drawing and ponder over those questions. You can check your answer in the formative quiz. So if we make a change to a part, we need to also make often changes to the assembly. So we need to, those changes will flow through our drawings. So thank you for listening to this presentation.